ಸ್ನೇಹಿತರೆ, 9ನೇ ತರಗತಿಯ ಎಲ್ಲ ಮುದ್ದು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ RK ಕ್ಲಾಸ್ಗೆ ಸ್ವಾಗತ. ಈ ಒಂದು ತರಗತಿಯಲ್ಲಿ 9ನೇ ತರಗತಿಯ ವಿಜ್ಞಾನದ ಘಟಕವಾದಂತಹ ಚಾಪ್ಟರ್ ನಂಬರ್ 4 ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಅಟಮ್ಸ್ ಈ ಘಟಕಕ್ಕೆ ಸಂಬಂಧಿಸಿದಂತೆ ಎಕ್ಸೈಜ್ದಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಕ್ವಶನ್ಸ್ ಆನ್ಸರನ್ನು ಚರ್ಚೆ ಮಾಡೋಣ. ಸ್ನೇಹಿತರೆ, ಇದುವರೆಗೆ ತಾವು ನನ್ನ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗದೇ ಇದ್ದರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ಲೈಕ್ ಮಾಡಿ, ಫ್ರೆಂಡ್ಸ್ಗೆ ಶೇರ್ ಮಾಡಿ. ನಾವು ಮಾಡಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ವಿಡಿಯೋಗಳನ್ನು ತಾವು ವೀಕ್ಷಣೆ ಮಾಡಬೇಕಾದ್ರೆ ತಪ್ಪದೆ ಪಕ್ಕದಲ್ಲಿರ್ತಕ್ಕಂಥ ಬೆಲ್ ಐಕಾನ್ ಒತ್ತಿ. ಈಗ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಅಟಮ್ಸ್ ಈ ಘಟಕಕ್ಕೆ ಸಂಬಂಧಿಸಿದಂತೆ ಎಕ್ಸೈಜಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಪ್ರಶ್ನಾವಳಿಗಳನ್ನು ಚರ್ಚೆ ಮಾಡೋಣ. ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಅಟಮ್ಸ್ ಎಕ್ಸೈಜ್ ಕ್ವಶನ್ ಆನ್ಸರ್ಸ್. ಫಸ್ಟ್ ಕ್ವಶನ್, ಕಂಪೇರ್ ದ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್, ಪ್ರೋಟಾನ್ ಆ್ಯಂಡ್ ನ್ಯೂಟ್ರಾನ್. ಕಂಪೇರ್ ದ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಪ್ರೋಟಾನ್ ಆ್ಯಂಡ್ ನ್ಯೂಟ್ರಾನ್ಸ್. ರೈಟ್ ಆನ್ಸರ್. First difference, electron nature of the charge is electrons are negatively charged. Proton are positively charged. Neutrons are neutral. Second difference, electron mass is 9 into 10 to -31 kg. Proton mass 1.67 to 10 to -27 kg. Neutron charge equal to mass of proton. Third difference, electron location extra nuclear part distributed in different cells or orbits. Proton location nucleus in the nucleus. Neutron in the nucleus. Next question, what are the limitations of J.J. Thomson's model of the atom? What are the limitations of J.J. Thomson model of the atom? Right answer. Limitation of J.J. Thomson's model of the atoms are: first one, it could not explain the result of scattering experiment performed by Rutherford. Next one, it did not have any experiment support. Third question, what are the limitations of Rutherford's model of the atoms? Limitations of Rutherford model of the atom are: it failed to explain the stability of an atom. It does not explain the spectrum of the hydrogen and other atoms. Describes Bohr's model of the atom. Describes Bohr's model of the atom. Right answer. The atom consists of a small positively charged nucleus at its center. The whole mass of the atom is concentrated at the nucleus, and the volume of the nucleus is much smaller than the volume of the atom. All the protons and neutrons of the atoms are contained in the nucleus. Only certain orbits known as discrete orbit of electrons are allowed inside the atom. While revolving in these discrete orbits, electrons do not radiate energy. This orbit or shells are represented by the letters K, L, M, N, etc. or the numbers n is equal to 1, 2, 3, 4 as shown in below figure. Bohr's model of atom: nucleus K cell n is equal to 1, L cell second cell n is equal to third cell M cell. Question number 5, compare all the proposed models of an atom. Proposed model of the atom given in this chapter. Right answer. Thomson model, Rutherford model, Bohr's model. Thomson model: an atom consists of a positively charged sphere and the electrons are embedded in it. Rutherford model: an atom consists of a positively charged center in the atom called the nucleus. The mass of the atom is contributed mainly by the nucleus. Bohr's model: Bohr agreed with almost all points as said by Rutherford except regarding the revolution of electrons, for which he added that there are only certain orbits known as discrete orbits inside the atom in which electrons revolve around the nucleus. Second, the negatively and positively charged are equal in magnitude. As a result, the atom is electrically neutral. The size of the nucleus is very small as compared to size of the atom. While revolving in its discrete orbit, the electrons do not radiate energy. Question number 6. Summarize the rules for writing of distribution of electrons in various cells for the first 18 elements. The rules for writing of the distribution of electrons in various cells for the first 18 elements are given below. If n gives the number of orbits or energy level, then 2n square gives the maximum number of electrons possible in a given orbit or energy level. Thus, first orbit K cells will have 2 electrons, second orbit L cell will have 8 electrons, third orbit M cell will have 18 electrons. If it is outermost orbit, then it should be have not more than 8 electrons. There should be stepwise filling of electrons in different orbits. That is, electrons are not accompanied in a given orbit if the earlier orbit or cells are incompletely filled. Question number 7. Define valency by taking examples of silicon and oxygen. The valency of an electron element is the combining capacity of that element. The valency of an element is determined by the number of valency electrons present in the atom of that element. Valence of silicon: it has electron configuration 284. Thus, the valency of silicon is 4, as these electrons can be shared with others to complete octet. Valency of oxygen: it has electron configuration 26. Thus, the valency of oxygen is 2, as it will gain 2 electrons to complete its octet. Page number 55. Explain with examples atomic number, mass number, isotopes, isobars. Give any 2 uses of isotopes. Atomic number: the atomic number of an element is the total number of protons present in the atom of that element. For example, nitrogen has 7 protons in its atom. Thus, the atomic number of nitrogen is 7. Mass number: the mass number of an element is the sum of the numbers of protons and neutrons present in the atom of that element. Example, atom of boron has 5 protons and 6 neutrons, so the mass number of boron is 5 plus 6 11. Isotopes: these are atoms of the same elements having the same atomic number but different mass number. For example, chlorine Chlorine has two isotopes with atomic number 17 but mass number is 35 and 37 respectively. Chlorine mass number, atomic number. Chlorine 1735, chlorine 1737. Isobars. These are atoms having the same mass number but different atomic numbers. That is, isobars are atoms of different elements having the same mass number. For example, neon has atomic number 10 and sodium has atomic number L1, but both of them have mass number as 22 respectively. Neon 10 22, neon L1 22. Two uses of isotopes. One isotope of uranium is used as a fuel in nuclear reactors. One isotope of cobalt is used in the treatment of cancer. Question number 9. Na plus has completely filled K and L cells. Explain. Right answer. Atomic number of sodium is L1, so neutral sodium atom has L1 electrons and its electron configuration is 281, but Na plus has 10 electrons. Out of 10, K cells contains 2 and L cells contains 8 electrons respectively. Thus, Na plus has completely filled K and L cells. Question number 10. If bromine atom is available in the form of say two isotopes 79, 35, 79, bromine 35, 81, calculate the average atomic mass of bromine atom. It is given that two isotopes of bromine are 35, 79, 35, 81. Then the average atomic mass of bromine atom is given by 79 into 49.7% means divided by 100 plus 81 into 50.3 divided by 100. Simplification ಮಾಡಿದಾಗ 3926.3 divided by 100 plus 4074.3 divided by 100. Simplification ಮಾಡಿದಾಗ 8000.6 divided by 100. 80.006 in it. Next question, the average atomic mass of a sample of an element X is 16.2 in it. What are the percentages of isotopes 816X and X818 in the sample? It is given that the average atomic mass of the sample of element X is 16.2 unit. Let the percentage of isotopes X818 be Y percentage. Thus the percentage of isotopes at 816X will be 100 minus Y percentage. Therefore 18 into Y divided by 100 plus 16 into Y, 100 minus Y divided by 100 is equal to 16.2. The simplification ಮಾಡಿದಾಗ 18Y plus 1600 minus 16Y is equal to 1620. 2Y plus 1600 is equal to 1620. 2Y is equal to 1620 minus 1600. Y is equal to 10. Therefore, the percentage of isotopes X818 is 10%. Percentage of isotopes 816X is 100 minus 10, 90%. Question number 12. If Z is equal to 3, what would be the valency of the element? Also name the element. By Z is equal to 3, we mean that the atomic number of element is 3. Its electron configuration is 2, 1. Hence the valency of element is 1. Therefore, elements with Z is equal to 3 is lithium. Question number 13. Composition of the nuclei of two atomic species X and Y are given as under XY. Proton 66, neutron 68. Given the mass number of X and Y, what is the relation between two species? Mass number of X is equal to number of protons plus number of neutrons. 6 plus 6, 12. Mass number of Y is equal to number of protons plus number of neutrons. 6 plus 8, 16. These two atomic species X and Y have the same atomic number but different mass number, hence they are isotopes. Question number 14. For the following statements, write T for true and F for false. First one, J.J. Thomson proposed that the nucleus of an atom contains only nucleons. This statement is false. A neutron is formed by an electron and a proton combining together, therefore it is neutral. This statement is false. Third one, the mass of an electron is about 200 times that of proton. This statement is true. And isotopes of iodine is used for making tincture iodine, which is used as a medicine. This statement is false. Rutherford's alpha particle scattering experiment was responsible for the discovery of atomic nucleus, electron, proton, neutron. Right answer, atomic nucleus. Next multiple choice question. Isotopes of an element have same physical properties, different chemical properties, different number of neutrons, different atomic numbers, different number of neutrons. Number of valence electrons in chlorine minus ions are 16, 8, 17, 18, 8. Page number 56. Which one of the following is a correct electron configuration of sodium? 28, 821, 218, 281, 281. Complete the following tables. Atomic number, mass number, number of neutrons, number of protons, number of electrons. Name the atomic species. Right answer, fluorine, sulfur, magnesium, deuterium, hydrogen, and atomic number, mass number, number of neutrons, number of protons, number of electrons. Dear students, if you have any doubts in this chapter, question answers, please share and subscribe my channel. Thank you.